What's going on, everyone? Today we'll be going over the advanced guide for Diels-Alder reactions. We're going to be going over these three problems right here. And if anyone hasn't watched my first video, the beginner guide to Diels-Alders, I'd recommend to go watch that, and I'll leave the link in the description. But throughout this video, we're going to be covering the three main steps to be able to solve any type of Diels-Alder problem, and we're going to throw some tips and tricks along the way. So stay tuned, let's go. Alright, so to get this guide started, we're going to first look at the first problem. And in this case, I'm going to give you the answers right here, and the final product is going to be this right here, but don't get thrown off by the weird formation. This is just going to be a representation, a 3D representation of the regular 6-membered ring that we're used to getting. So bear with me and we'll work through it. So the first thing that I always like to do when working with Diels-Alder problems is to number all the carbons directly touching the double bonds. 4, 5, and 6. And I'm going to number them all on the product side as well to give you a feel for how the product side is numbered. And it's going to show you some similarities between these two structures. So if we go and number them 1, 2, 3, 4, 5, and 6. Then for this structure, we're always going to want to start here. 1, 2, 3, 4, 5, and 6. Next, we'll go in and draw our mechanism. Carbon 6 attacking carbon 1, pushing over the double bond between carbons 2 and 3, which pushes this double bond to attack carbon 5. So if we see what happens, carbon 6 attacked carbon 1, which is why we see carbon 1 and 6 attached here and here. Then this double bond moved over between carbons 2 and 3. That's why we see the double bond between carbons 2 and 3 here, and 2 and 3 here. And then the carbon 4 double bond attacks carbon 5, which is why these two are connected on the product side. Okay, so now we can do the substituents or the attachments on the diene in the diene file. So if we start with this one right here, we see that carbon 6 has a methyl group attached to it. So what I always like to do to throw on the attachments, first find the carbon on the reactant side that has an attachment, and then find the same carbon on the product side that has the attachment. So we know it's carbon 6, and we just draw in our methyl. Similarly, find carbon 6 and attach the methyl. Okay. Next thing we do is we have to find this carbon right here. So this carbon is touching carbon 1 and 4. So we go to the product side, and the only way to make a touch carbon 1 and 4 is to draw a tent-like structure over the 6-membered ring, like so. Because if you see, this carbon right here is going to be touching both carbons 1 and 4. Okay, so this is why teachers or professors don't really like you to draw it in this formation, but instead they want you to draw in this 3D formation to be able to draw this tent-like structure. So this is going to be it for the first one. We're going to go into 2 more problems, and I'm not going to give you the products, so we're going to be able to work through them together, and we'll see where it goes. Alright, so for the second problem, we're going to work on these 2 molecules right here. And one tip I want to give before we start to help predict the end product a little bit better is that whenever the diene, this molecule right here, is going to be a ring, we know that we're going to have to draw the 3D representation of the ring, so that weird structure like this. Okay? So, okay. First thing I always like to do, number your carbons that are directly touching the double bond. 2, 3, 4, 5, 6. We have 6, and because this is a ring, we know that we're going to have to draw a 6-membered ring in a 3D representation. So let's go in and draw our ring. Okay. Next, we can go ahead and actually number this, and then we'll start drawing out the mechanism. So again, like we always start, these are the 3 important steps. Carbon 6 attacking carbon 1. This double bond moving over between carbon 2 and 3, and then this double bond from carbon 4 attacking carbon 5. So if we see what happens, 6 attacked 1. That's why these two are connected. This double bond moved between carbons 2 and 3, so we can go in and draw our double bond between carbons 2 and 3. And then a double bond from carbon 4 attacked carbon 5, which is why they're connected. Okay, now we have to worry about the attachments. So we have 3 carbons unaccounted for, or 3 attachments. So let's start with the diene file first. So this one right here, this double bond is going to be a trans double bond, meaning that the attachments on either side of the double bond, this one and this one, are facing opposite ways, are going opposite directions. So their stereochemistries for this attachment and this attachment are going to be opposite to one another. So one's going to be wedge, one's going to be dash. So the way I like to throw on attachments, find your carbon with an attachment on the reactant side, and then find it on the product side, and then draw in attachment with the appropriate stereochemistry. So if we make this one dash, the next one has to be the opposite, so wedge. Same thing, find carbon 5 on the reactant side, find it on the product side, then draw in your attachment with the proper stereochemistry. Okay, next we'll find this carbon right here. This carbon is touching carbons 1 and 4. So we have to make a carbon on the product side that's gonna be touching carbons 1 and 4 as well. And how you do this, you just draw a little tent, that's what I like to call it, over the structure, and this represents this carbon as it's touching carbon 1 and carbon 4. Alright, so we're gonna do one more problem after this, and we're gonna have to combine everything we've learned so far. Alright, so to hop into this last example, we'll be going over these two molecules right here. And again, the first thing that I like to do when looking at these problems is to identify that we have a ring as our diene. So we know that our product is going to be in a 3D representation of a ring. So let's number our carbons: 1, 2, 3, and 4, 5, and 6. Now we can draw in our 3D representation of a 6-membered ring, like so. Okay. Next, what we can do is draw in our mechanism. And before that, actually, let's go ahead and number this to get this out the way. 5 and 6. Alright, so carbon 6 is going to attack carbon 1, pushing over the double bond between carbons 2 and 3. This is going to cause a double bond from carbon 4 to attack carbon 5. So let's see what happened in the mechanism. Carbon 6 attacked carbon 1, pushing over the double bond between carbons 2 and 3. So now we have 1 and 6 connected, and we have a double bond between carbons 2 and 3. This led to carbon 4 double bond attacking carbon 5. So that's why we see carbon 4 and 5 connected. So now let's worry about the attachments. So we have these two attachments on the dienophile and these two carbons on the ring. So what we can do is focus on the dienophile first, and we see that this is going to be a cis double bond. That means that the attachments on either side of the double bond are going the same way. They're both going to the right. So we know that their stereochemistry are going to be the same. So they're either going to be wedge-wedge or dash-dash. So how I like to throw on the attachments is to find the carbon on the reactant side first that has an attachment, find the same carbon on the product side, and then draw it in with the correct stereochemistry. So for this case, we'll just do dash, but it could also be wedge. Then we could find the same one for carbon 5 on the reactant side. Then we find the carbon 5 on the product side, and then we make it a dash. Again, they have to be the same because the double bond is cis. They're going the same direction, both to the right. Alright, next thing we can do is worry about these. And what I'll do is name these carbons X and Y. So if we see carbon X is touching carbon 4 and carbon Y, and carbon Y is touching carbon 1 and carbon X. So X and Y are touching each other, and X is touching 4, Y is touching 1. So we need to draw two carbons that are touching each other, and carbon 1 and 4. So how I like to draw this, it's going to look a little weird, but similar to the tent, we're going to draw a line up, and then connect carbon 1. So now we know carbon X is going to be the one touching carbon 4. So carbon X is this one right here. Then we have Y touching carbon 1. So Y is touching X and 1, and X is touching 4 and Y. Alright guys, that's all I have for you today. Thank you guys for watching. Please let us know if you have any questions in the comments, and let us know if you have any other topics that you want us to go over.